Today we'll look at the last FRQ of the 2015 AP Calculus AB exam. It's of course a non-calculator question, the last one of the 4 non-calculator problems in the exam. The mean for this exercise was a little lower than the overall mean. Many students earned some points in each part, however, just like the 5th problem, 20% earned no points on this FRQ. I called it implicit differentiation so that it fits with the FRQ by genres that I prepared, and we'll see the question now. Consider the curve given by the equation y cubed minus xy equals 2. It can be shown that dy dx equals y over 3y squared minus x. And then you have a bunch of questions. It can be shown that dy dx equals y over 3y squared minus x. This question could very much be one of the questions you have to show. So we are going to do it. I think there's 2 reasons why they don't ask you to do that. The first reason is that you're going to have to do something similar in question C. And the second reason is that there's a lot of points when you have to show something like that, and they already probably had 9 points distributed between A, B, and C, so there basically wasn't enough room. But we'll do it because you can very much expect to have a question like that in such an FRQ. And it will often be formulated as prove that dy dx equals y over 3y squared minus x. So you have to start with the original equation and reach this conclusion. The reason why they say prove that, giving you the actual derivative, is that they want you to be able to use the expression in further questions, even if you fail to actually find the correct answer. So we're going to do that. We're going to start with the equation given and try to prove that dy dx equals y over 3y squared minus x. So this is the equation given. We have 3 terms here, and we'll differentiate them separately. So the derivative of y cubed is 3y squared times y prime. That's the inside derivative. The derivative of x times y, it's a product, so we have to use the product rule. The derivative is u prime v plus uv prime. Here it is, u prime v plus uv prime. After I've done that, I want to make sure that I don't make a classic mistake to add a negative sign here without parentheses. We are subtracting the entire derivative of x times y. So we're going to have minus y minus xy prime. Last term on the other side of the equal sign, we have 2. The derivative of 2 is 0. So here's the first step to solving this equation. And that can already be worth 2 points if it was one of the questions in the FRQ. There's a lot of points to earn when we have to solve such problems. I'm going to remove the parenthesis now, so 3y squared y prime minus y minus xy prime equals 0. If I want to solve for y prime, I have to factorize. I have a y prime here, I have a y prime there, so factorizing, I get the 3y squared minus x times y prime, and then the minus y that I already had here. From here on, it's easy. I'm going to add y, and then I'm going to divide by 3y squared minus x. Conclusion, y prime equals y over 3y squared minus x, and I double check, yes, it's what I had to show. So if that had been question A, you would have 4 or even 5 points sometimes that can be earned in the question. Let's see what the actual question was. Question A, write an equation for the line tangent to the curve at the point negative 1, 1. When we are looking for a line tangent to the curve, we need 2 things. We need a point, and we need the slope at that point. So the point is given, that's great, and then we're going to have to find the slope, and that obviously is done by using the derivative. Let's look at student A. The student wrote that we need a slope and we need a point. The point is negative 1, 1, and the slope is dy dx, or y prime. And to find it, we need to substitute x equals negative 1 and y equals 1. The student does that and finds that y prime equals 1 over 4. Moving on, point-slope form, we can immediately write the equation of the line y minus 1 equals the slope times x plus 1. From here on, the student continues until the student reaches the slope-intercept form, but that is not necessary. The student boxes the answer, which is always a good habit. Before we move on and look at the points, I want to insist on something that I saw several times this year. I think maybe I've been confusing you at one point. When you find y prime, the answer you get is the slope of the tangent line. There's nothing else you have to do, and that's the typical question. Now, it happens, but rarely, that the question may ask you for the slope of the perpendicular line, which is also sometimes called the normal line. In that case, you have to take the inverse reciprocal of your answer. So in that case, m would be equal to negative 4. But this question here, the perpendicular or normal line, is really an exception. Most of the times, the question is asking you about the slope of the tangent line, so don't start flipping 1 over 4 and changing the sign in these cases. Be careful. So there were 2 points to be earned in that question. The first point was earned if the student found the slope of the derivative, and the second point was earned if the student wrote the expression for the line. And I put the 1 here because this already earned the point. From here on, it was kind of a risk from the student. If there had been a mistake in these 2 steps, the point would have been lost. So this is where you can stop. And we'll see that student B does actually that. Student B, dy dx equals 1 over 3 times 1 squared minus negative 1, so the student correctly substituted x equals 1, y equals negative 1, and finds that the derivative is 1 over 4. Immediately jumps to the answer, y minus 1 equals 1 over 4 times x plus 1. That's perfect, simple, clear, and the student lost very little time on that problem and earned full credit. Our third student got the right idea. The slope is 1 over 3 times 1 squared minus negative 1. Sadly, they made a small mistake here, 1 over 5 instead of 1 over 4. After that, the student wrote the correct expression for the line. There's an error carried forward here, but apart from that, it was correct. So the student lost the point for the slope, but did earn the point for writing an expression for the line. 1 point out of 2. Question B was very difficult. Find the coordinates of all points on the curve at which the line tangent to the curve at that point is vertical. If a tangent line is vertical, that means the slope is undefined. So there's different ways how the slope can be undefined. If it was a sharp turn, the slope would be undefined. If there's a vertical tangent line, the slope can be undefined. If the function is not continuous, then the slope is undefined. But in this case, we are just looking at vertical tangent line. So the slope is undefined, and when could this expression be undefined? When the denominator equals 0. The student sets up denominator equals 0, solves for x, and then that was the tricky part. We don't just, this is not enough, because at these points, yes, the denominator is undefined, that's great. However, not all these points are on our curve. We have to find points that are on this curve such that x equals 3y squared. So we have a situation where there's two equations with 2 unknowns, x and y. The student solved for x here, so then he can or she can substitute x in the equation for the curve. So the student gets y cubed minus, and then for x, 3y squared times y equals 2, which is written here. After that, the student solved this a simple equation, y cubed minus 3y cubed equals 2, negative 2y cubed is equal 2, y cubed equal 1, y cubed is equal negative 1, and therefore y equals negative 1. So this is the answer for y. We also have to find the value of x. We go back to here. That was one way of doing it. So what did the student use here? The student used this equation and substituted y equals negative 1. And here y equals negative 1. So the student solves and finds x equals 3. The other possibility was to substitute y equals negative 1 here. 3 times negative 1 squared equals 3, so x equals 3. In the end, the student writes the answer to the question: there are vertical tangents at the point 3, negative 1. So the first point was earned if the student realized that the denominator was equal to 0 and wrote an expression stating that. If you just wrote denominator equals 0, that wasn't enough, but if you wrote a mathematical expression stating that, then you would earn a first point. The second point was earned when you substituted somehow, in some way, you substituted x in 3 in here, and then there was a last point that you could earn, but only at the very end if you actually gave the answer. If you just write y equals negative 1, x equals 3, I don't know, it's much better to actually really make sure that you're answering the question. So the point is 3, negative 1. Second student. The second student also realizes that the denominator has to be 0 if there's a vertical tangent. So 3y squared minus x equals 0, that's 1 point. Now after that, the student does something a little bizarre, and I'm pretty sure this is the only point the student earns, yes. I'll just talk about that, it happens sometimes. The student adds from here, the student adds 2 on both sides of the equation. So 3y squared minus x plus 2 equals 2. Why does the student do that? The intention here is to have this equation here match with our original curve. So the intention was good. And now since this is equal to 2 and this is equal to 2, we can say that this expression here is equal to that expression here, right? That's very well, that's perfect mathematically. However, there's a big issue with that. When you have two equations and you want to solve a system of two equations with two unknowns, you want to get rid of variables. You want to be able to get rid of x or y. Here, what does the student do? They just manage to get a longer expression that still has x's and y's. After that, the student really realizes that they are stuck and just gave up on this problem. So, only 1 point for this problem, which is pretty good because it was tough. Our last student, I'm not going to spend any time here because I think that student was confused, so just 0 points for student C. Question C, here we have to use implicit differentiation to answer the question. We are looking for the second derivative. Notice that this is the expression for y double prime. And once we will find y double prime, we'll need to find the actual value at the point x equals negative 1, y equals 1. So recalling question A, the slope at the point negative 1, 1 was 1 over 4. So we're going to use that later on. This is really the first line that we should do. We have the first derivative, so we need to differentiate again. And what does that mean? We're going to have to use the quotient rule. U prime v minus uv prime all over v squared. The student does that. U prime v minus uv prime over v squared. Sorry, actually, this is uv prime. But it doesn't matter. If you a times b equals b times a. But that's what the student did. After that, we have this y prime here and this y prime there, so that's where we use the 1 over 4. Y prime is equal to 1 over 4. We can plug it in. We can plug x equals -1 and y equals 1 in as well, and we reach an arithmetic expression that can be simplified, and we finally get 1 over 32. All we can conclude is that at that point the curve is concave up, because y double prime is a positive number. Very good job. 4 points. I told you earlier when we did implicit differentiation from here that there's always a lot of points for working an implicit differentiation correctly. There were 2 points for this step here, so using the quotient rule and doing everything right. There was 1 point for substituting y prime equals 1/4. I put the point here, but I bet the point was really earned once this 1 over 4 was plugged in here. And lastly, there was 1 point for just making sure we get the right answer. Our second student starts with trying to find the second derivative, u prime v minus uv prime over v squared. This is correct. Then the student also correctly substitutes y prime. This student actually substitutes y prime. They substitute the entire expression here. So this is why it becomes big. It's great. It's clever. It's correct. There's no mistake. But it's a little bit longer than actually remembering dy dx is equal to 1 over 4. We had found that before. So the student does that, it's correct, and then when solving this, there's a tiny mistake right here. This should be plus, it's just a distribution mistake, minus this plus 1. So a good job overall from that student. 2 points for finding the derivative, 1 point for making a substitution for dy dx, and then just a small mistake that is quite costly in the end. Student C finds d squared y dx squared, so uses the quotient rule well and gets 2 points for that. Unfortunately, the student doesn't substitute 1 over 4 and doesn't go to the end of the question. So that's it for the 6th FRQ for 2016. We'll just read a few common mistakes that were commented on by AP Central. In Part A, the most common errors were simplification and arithmetic errors. In Part B, it appeared that many students did not understand the question. Some of these students set 3y squared minus x equals 0, which was correct, denominator equals 0, but never connected this to the curve given by the equation y cubed minus xy equals 2. So this is true, the denominator has to be equal to 0, but it also has to be on the curve. So we need to use both of these expressions. In Part C, most students used the quotient rule to find y double prime. Some students made errors in applying the quotient rule. The most common errors included a reversal in the numerator, a missing factor of y in the second term of the numerator, and a missing square in the denominator. So just a reminder, if y is u over v, it's u prime v minus uv prime. You can't flip these two terms, just remember that. And it's all over v squared. There were also many presentation errors such as missing parentheses. Most students were able to substitute for dy dx, however many students made simplification errors in arriving at a final answer. Once you only have numbers, so once it's only arithmetic, you don't have to simplify, so maybe that can save you a small mistake which can cost 1 point. Recommendations: teachers should emphasize the connection between dy dx and the slope of a curve, so the derivative tells you what the slope of a curve is at a point. Students need more practice in finding the second derivative when the first derivative is given. Students must use proper notation and grouping symbols when presenting a mathematical expression. That's all. Thank you, and I hope this helped. Bye.